Hello everybody, today we're going to be writing the complex number 2 minus 2 root 3i, and we're going to be writing it in its polar form today. So let's get straight into this. So first of all, with this, you want to find the radius first, okay? You want to find r. So we're going to say step 1, find r. And to find r, well, this is given by the formula, and it's the square root, and it's going to be the real part squared, so it's 2 squared, and then it's the imaginary part squared, which is negative 2 root 3 squared. And if you're wondering why this is, well, the way I like to think about it is it's sort of like a triangle, right angle triangle, and you have your real axis, your imaginary axis. On the real axis you have 2. On the imaginary axis, sorry, you have negative 2 root 3. And of course, simply by Pythagorean's theorem, a squared plus b squared equals c squared, well, this means that this angle, sorry, not this angle, this side, which we call r, is going to be the square root of a squared plus b squared, which is just 2 squared plus minus 2 root 3 squared. So that's where this formula comes from. So now we're just going to compute this. This is going to be the square root. This is 4. Negative 2 squared is 4. Root 3 squared is 3. So it's going to be plus 4 times 3. Sorry. Which is going to be 16. And of course this equals 4. So r is 4. Okay, next up we need to find the argument of our complex number z. So in this instance, z is 2 minus 2 root 3i, so it's going to be the argument of 2 minus 2 root 3i. And for this, once again, I sort of like to visualize it as a triangle. So let's go back up to our triangle up here. So we have a certain angle theta, and then we worked out that the radius here, or the hypotenuse, is 4. So then the angle theta, simply by some trigonometry, we know that the angle theta is going to be, theta equals the arc sine, okay, the inverse sine, and its opposite over hypotenuse, so it's going to be negative 2 root 3. It's negative 2 root 3 divided by 4. Okay, very nice. It's going to be the arc sine of, now we can actually reduce this down, to negative root 3 divided by 2, which of course is none other than negative pi by 3. So we found that theta equals minus pi by 3. Okay, very nice. And also you can do this with any of the other trigonometric functions. For example, you could do it with tangent. You could simply take the arctangent of negative 2 root 3 divided by the adjacent 2. You would of course get a little bit of cancellation here, giving you just negative root 3 over 1, and of course you get negative pi by 3. So this works for all trigonometric functions, obviously. So putting this all together, we have that r, the radius, is 4, and theta, our angle, is none other than minus pi by 3. So all we need to do now is simply write this in the polar form, and so we're just going to say 2 minus 2 root 3I is equal to, and the polar form for this is the radius times the cosine of theta plus I times the sine of theta. Okay, very nice. So this is going to be 4, our radius is 4, and it's going to be the cosine of negative pi by 3, so it's negative pi by 3. But of course, cosine is an even function, so we can actually get rid of this negative. So we just get the cosine of pi by 3, and plus the sine of minus pi by 3. But I'll tell you what, we can just get rid of this negative here, and we'll just put it out in the front. And here is our answer. So, this is our answer for today's question. This was the polar form of the complex number 2 minus 2 root 3I. So I hope you enjoyed this video. Bit of a different one today, but yeah, I hope you learned something new today, and leave a like and subscribe for more content like this, and goodbye.